Sorry about that. Pretty wizard. Nice. Okay. It's pretty magical then. Is that what you're saying?
Pretty rad.
Okay.
You don't know what wizard means, really? What are you, some sort of square?
I am very much a square, yes. Okay, my apologies for being a square then. Okay, let me give you an example, okay? And then you guys are gonna work on this as a warm-up. Oops, this is not, this is a new document camera here. And I know it's a little bit blurry, but it'll focus in just a second, or I'll make it focus in just a second, okay? So here's your warm-up. And also, so I'm gonna ask you for two things. So let's see if I could focus that really quick. That's it. Okay, let me see if I wrote more. So one will be, can you give me the midpoint formula, like a general midpoint formula, and can you give me the distance formula? So that's one part. Okay, so let me see if I can. Okay, good. Okay, that's one part. The other part is I'm going to give you a triangle with features that will seem familiar to you. There we are. This would be 80 degrees plus degrees. Okay. And let's see, this is 2y plus 2, and this is 4y minus 2. So let's see, and this is corner number 1, this is corner number 2, or 3, sorry, and corner number 4. Or no, 1, 2, sorry. I'm all over the place, I'm sorry. This is corner number 1 on the upper section of the triangle, that's corner number 2, and then the lower right-hand corner of this triangle is corner number 3. Okay, I want you to solve for y and x on the second problem, and that's a degree sign, okay? So go ahead, find a space on a whiteboard, and please get to work. So there's a whiteboard now in front of Toller. I'm sorry, where you were facing Toller. There's a whiteboard there. There's a whiteboard behind Toller. There's hopefully more whiteboards available now. Elizabeth, you have one now readily available to yourself. Alex, you have one behind you as well. And then, of course, you have just the standard whiteboards over here. Okay? So go ahead and get to it. I want to see the midpoint formula, the distance formula, and solve for y and x. This should take you about 10 minutes in total to do this. Okay? Good luck. Let's see if you can recall this.
Mr. Lee,
Yeah?
is it possible for you to post the previous cheat sheets anywhere?
I'll try, yeah. I always because I have other things I try to prioritize. By the time I get to anything extra, I'm already asleep. So
Okay.
yeah, I'll try my best though. Is it getting too stuffy here? Cheyenne, your exams. I don't have. I'm just kidding. Okay, so this is going to be your exam. It's the same format it's always been. All your final answers go on this final cover sheet in the front. Okay. And first part's multiple choice. You may use a calculator for the calculations in the back here. Okay. That should be it. All right, so you have until about 11 to finish this exam, which gives you about an hour and a half. Okay, so let me do this and give you a calculator you can borrow. Okay, I was just maybe actually working at that table, or you know what? Yeah, go ahead and work on that table that let's see. Houston needs. Sorry. inclusive. Yes. You should. And make sure to come in for the audit. Alright.
I guess if you
Oh, really?
yes.
Yes, we can do that. Okay, we can do just the last day, so you can get a little bit more time. Yeah, that will be better. So, what time do you give me a very strong time? So before 1, so that means what time are you getting?
Alright, that's like
What's the most probability? 10-ish. Okay. So I gotta keep that as 8, right? 8. If you need any help, please let me know. I'm doing some other things right now, so just come up to me and ask if you have any questions. Who here is in my 8th grade science class? I am. Okay, all right, please come over here in the meantime. So if you're in my 8th grade science class, please come over here. What's on your shirt?
oh, you gotta make sure.
Okay, so I need everyone that's doing the science fair in my 8th grade class to essentially do this. Actually, anybody can. So, okay, so there's 2 forms here. So actually, if you're in my chemistry class as well, please come up to me. Honors or regular chemistry class. If you're in chemistry class, please come up to the front here. Okay. So, you're gonna be okay. So because you started science fair late. Okay. So you're in my science class. Okay. And Alexander, and then anybody else. Don't worry, guys. Just you. The rest of you guys continue on. This is just for my science class. No. Well, no, I'm just kidding. No, you're not. Okay. So I'm gonna email this to you guys, but since you guys are here, you guys can just pick this up. You guys need to fill this out, this form with this thing right here. Okay? This key, basically. Okay? You need to fill this out and basically give this to me. I have to give this to Mr. Higgins. I don't know if you remember this from last year, but it's just like a summary of like all the different projects. So for the science fair. So this helps you answer this question. How would you describe your categories of your science fair project? Right? Would you say it's plant science, chemistry? Would you say it's earth science? It's just good for us to know in the science fair we've had 100 people do math science or something. Okay, or, you know what I'm saying? So it's just an example. And then here, the science course you're taking, if you're in the 8th grade science class, you just say 8th grade science, okay? Or physical science, 8th grade physical science. And then if you're in chemistry, you just say chemistry. If you're in chemistry honors, you say you're in chemistry. Okay? Everybody got that? Okay, so each of you guys get one of these 2 piles. Please remember to turn this in Friday next week.
Finished everything. I finished online. Midpoint Formula.
So you're gonna come in to me first, and then I will inspect this real quick, like, hey, you first got this, you got this last minute. And then if you're all good, then I just send you to the auditorium, and then there should be very clear. 8th graders drop off their stuff here. So here's the midpoint chemistry class here. Our sections are if you're style, I thought it was gonna work on chart.
Yeah.
This would be.
Can't catch the mouse.
Alrighty, so do I have any takers for the midpoint theory or the midpoint theorem or formula? What is the midpoint formula? Are any of those correct that we see on the board there? I see that person that wrote in green and red is good, but they're missing maybe one part. Very, very, very almost non-important, seemingly non-important detail. What is it?
X equals.
It's not even x equals. No, it's not x equals.
Parentheses.
What do you? Well, Yusuf was kindly raising his hand in the back, like, I know, but Colton just kept going. Okay, what do you think, Yusuf? Yes, so both of you guys were correct. I was just kidding. Okay, so yes. So why is it that I stress the importance about having the parentheses in the midpoint formula? Why is it that I'm stressing the importance of the midpoint formula here? Does anybody know? So you don't have to draw this, but this is the midpoint formula specifically about looking at graphs. So let's say if we had a line going from here to here, from this xy coordinate to this xy coordinate, right? If I wanted to find the point in the middle, I would take the coordinates of this guy, which is x2 comma y2, and I would subtract them from the coordinates down here of x1 comma y1. That's where the midpoint formula comes from. You have to take the x values and you have to subtract them from each other and divide it by 2. Logically, that will give you this midpoint, this whatever this number is here. And then to get the midpoint coordinate for the y value, it's the same thing. You just take the y values, y2 and y1, you add them, and you divide them by 2, you should get the y coordinate for whatever this coordinate is here for the midpoint. Does that make sense? Okay. The distance formula, let me see if anyone else saw the... Yes, who wrote on this board over here for the distance formula? No one wants to grab any credibility? That was you?
Yeah.
Okay, good. You should be proud of it. Yeah, that was absolutely correct. This is the midpoint formula. It should be the distance, d, is equal to the square root. It's very simple of x2 minus x1 squared plus the difference of the y values squared. Whoops. So let me extend this umbrella over here, okay? So what this tells me is if I took these two values here, these 2 points up here in this example again, in this graph, and I subtracted them from each other, I squared them and I added them, and I took the square root of the whole thing, that would give me the distance, this approximate distance of this line. Okay? Very good review. You might need that today. I don't know. You might need it, right? What did you guys get for x over here? Anybody like to volunteer to give me their answers here? Would you like to see the answers? We see. So you got x equals 7. Oh, did I do something incorrect here? Okay. So how did you guys solve for x? Anybody like to tell me how they solve for x? No? Note takers? Alex? No?
Well, it's an equilateral triangle, right? Or no, the two sides are equal, so you can equal them.
Okay, so you're talking about for the y, right? Okay, so for
the x, yeah.
For the x or the y?
I solved for the y first.
Okay, so for y, we knew that these two sides were equal to each other, so that's not too bad. We did 4y minus 2 is equal to 2y plus 2. And then you did some algebra, correct? By adding 2 to both sides. And you have 4y is equal to 2y plus 4. And then you subtracted 2y from both sides, giving you 2y is equal to 4. And then you divided both sides by 2, right? So you should have gotten y is equal to 2. However, how about x? That's a little bit tricky, more tricky. What do we know about this triangle for sure? We don't know for sure if it's equilateral, but what do we know about this triangle so far? It's at least isosceles. So we know that these two sides were at least equal to each other. What does that indicate about any angle relationships within this triangle?
They'll also be the same.
Which ones, though? Will they all be the same, or will only a few of them be the same? Yes, Matthew.
Two bottom ones.
The two bottom ones. So you can look at it in terms of like a relationship across from the side that is part of the isosceles triangle relationship. Okay? So these two angles are going to be the same. However, again, how is that going to help us? I don't understand how that would help us. Yes, Matthew.
All the triangles or all the angles add up to 180.
What do you mean? All the
No.
angles
Or all
or
the measurements.
all the measurements add up to 180. So if we were to look at this triangle, we would say angle 1 plus angle 2 plus angle 3 should equal to 180 because of the triangle angle sum theorem, right? Can we substitute in any values so far? Angle 2 is definitely 80, right? So that gives us angle 3 and angle 1. Okay. Now what? Now what should we do? Yes, Matthew.
Can't you substitute angle 1 and angle 3 for 6x plus 8?
So yeah, because we know that these two angles are the same. We know that angle 3 is, 6x plus 8. But since they're the same, angle 1 should also be 6x plus 8. Little trickery right there. Okay, plus 80 is 180. My recommendation is to first combine like terms. So I know I have 6x and 6x. That is 12x total if I added them both. And 80 plus 8 plus 8. Quick math. How much does that equal? Besides Matthew.
96.
96. Okay, very good. Is it that this is redundant for you guys and you guys are not wanting to volunteer? Like, okay, so we're going to subtract 96. Quicker math. What is 180 minus 96? Except Matthew. Okay. Yeah, Elizabeth? 84? Let's see, 84. Yes, that's correct. Yeah. And then you divide both sides by 12. I'm sorry about that. You guys can't see that. Okay, there you are. 12x equals 84, and we divide 84 by 12. You should have gotten 7. Whoops, and my key was absolutely incorrect. I put 4 for some reason. Okay. Any questions so far? Okay, very, very good, guys. Let's go ahead and move on to our last and final section today. So if this takes up more time than I anticipate, then, or it takes up less time than I anticipate, we have extra time, then I'll leave the floor for you guys. Just ask me questions for review. I don't think we're going to get to that point, so I'm sorry. But I would highly recommend just study the review questions, okay? Review questions that I posted on the cover sheet, right? And these should be good for the final, okay? Wink, right?
So, didn't you say like half the test is going to be stuff on this one, the other half is going to be review?
Yes, so they're equally important. But you should be good with just the cover sheet alone, okay? And also coming to class really helps, just because you get a good idea of what things I think are important. Okie dokie. So let's take a look at, so in order to look at coordinates and so the whole point is we know a lot about triangles now, right? You guys are clearly you guys find this redundant almost, like, Mr. Wee, I'll just let him do the work, but I think I already kind of get this, okay? Now, though, let's add an extra challenge and step to this, okay? We're going to apply everything we know about the triangle to coordinates and graphs. Like this, here. It's not going to be much different. We're just going to combine two things, like stuff that you learned from Algebra 1 and then stuff that you just learned from this section, right? Some coordinate graphing and then triangles. Why would this be a useful skill, by the way, in order to do this? Anybody think of like any applications or anything like in a job that we might need to use this? Can you think of a scenario we might need to use this? What do you think, Ainsley?
Basically anything in construction.
Anything in construction, right? I mean, if we build a house that looks like a triangle, okay, and we might want to know some relationships between the angles and like maybe the sides, okay? Maybe you want your house to look specifically like an isosceles triangle from above, okay? And in terms of the aerial view, okay? Like looking down, like, oh, wow, okay. Yeah, it's very specific, right? It's just one of the many shapes you're going to have to apply to a coordinate grid, okay? So let's have a look at this here, this triangle, okay? This is going to be your first taste of having to graph a triangle such as this with these sort of coordinates. Now, I understand that at point O, let me see if I have my clicker here, right? My laser clicker here. I understand that that's 0, 0. But why is it that this is 0, comma A, but yet this is B, comma 0? Why is it those letters? Why aren't they the same letters? I mean, why do I have all these? Why do I have any of these values? Can you at least explain to me one, Matthew?
Well, because the point is along the y-axis,
Okay.
so the point, the unknown point would be the y value.
Why isn't X any other value? Just as kind of review.
Y is x.
Why is X 0 in this
Because
coordinate?
it's along the axis.
It's along the axis, so it has no X. The X coordinate is just right at 0, right? Okay, and then answer me this. How come this, however, is B, comma 0? Someone else. Okay, someone else. Do you want to go first, Jeremy? Go ahead.
Okay. So the x-axis is okay, so it goes along the x-axis, so it's the same thing as the y-axis, just on the x-axis. So that means that
The Y coordinate is
0
0.
is on the y-axis.
Very good. Can you answer me why that I didn't have this equal to A? Why couldn't they both be A?
Because there's no telling if it's exactly the same without there being numbers on the graph.
Yeah, so if I implicated that these are both A, then that would have implied that they're both the same, but we don't know that, right? And as far as you know, what kind of triangle is this?
Right.
Okay, it's a right, you're right. It is a right, but it's also another type of triangle, as far as we know. It starts with an S. You're super close. I mean, he was saying it kind of right, but he was just kind of missing the first letter. Anybody hear what he said?
Scaling?
Yeah, it's a scalene. What does scalene triangle mean?
Like none of the sides are equal.
Yeah, no, we don't know if any of the sides are equal. Okay, so think about that if you wanted to prove it to be anything more than being a scalene triangle. Okay, so we're gonna add some stuff to this. Okay, so now you know how to graph it. Let me see what else I want to go over. And let's go over example number 2, or was it number 3? Okay. Oh, just really quick. This is a very quick exercise. Super duper quick. Go on the whiteboards really quick. Redraw this triangle and give me the correct coordinates really quick. Just really quick. This is a super fast one. This is going to be like maybe a minute, 2 minutes, maybe 5 minutes. I don't know. Just give me the coordinates for this triangle. Oh, don't look at that. Oh, one more thing, just to make this more complicated. This is an isosceles triangle. Uh-oh, what does that mean, Mr. Lee?
2 sides are equal.
2 sides are equal. What is that going to do to the coordinates, my friends? I don't know. I don't know.
Which sides are equal?
Oh, these 2 sides are equal. OY and YZ are equal. Sorry.
So OY.
OY and YZ are equal in measure.
Okay, so that means angle O and angle Z. So wait, isn't that X, not O?
This should be in the middle of O
Isn't
and Z.
that X?
So basically, huh?
That's X, not O.
Oh, that's just 0. Sorry.
Yeah.
Sorry, guys. That's X, Y, Z, not O. That's literally 0. I'm sorry about that, guys. That's 0. Mr. Wee messed up. Okay, that's X, Y, Z. Sorry.
And is X at 0, 0?
Huh?
It doesn't say. It could be
Yes,
like
X is 0, 0. So X is 0, 0. It is at the origin. Okay, but then I'm not gonna tell you anything else. I'll say that Y should be in the middle of 0 and Z, sort of like in its relationship.
Here's the answer.
Why?
You can't really assign a value for y.
Good.
Yeah. Oh, no, this one's zero. Yeah.
Do you remember?
What is the z for?
So then I think these two are congruent. So that's going to be.
Oh, that's true. It can't be. I'm sorry.
Those 2 sides are congruent. So then it would be
Are you sorry, Alex?
one A. Right, because it's
So
so
you still have
we would have
for notice, how did they replace? They basically just made the black and white, but he still kept the black out. Why couldn't they make it black still? I woke up and they put a black button. Do you put a black button?
I know.
Anybody come up with it? Oh, that's a good one.
Here we are.
Past that.
Huh?
I don't know. I was tired.
Anybody got it here?
You're close, but A to half of A, but yeah, what is it? Half of A what?
What?
I don't know. Yeah, that's half of A. Apple.
So you have to make it up.
I have to make it up.
Yeah, what would it be if you had to make
Jeremy,
it up?
what is it?
If you had to assign some kind of variable to it.
Oh, variable.
It can't be what you set as A, right? We don't know if it's that high, right? So what would you have to name it?
B.
Okay, that works. Just name it something. Yeah, anything else. You're good. Okay, I'll give you about 1 more minute to come up with this. All right. It's gonna blow your mind. You guys ready? Because you have to be used to making your own triangles. In fact, in the future, you gotta prove theorems by not numbers, but you gotta like make up like variables and stuff. You gotta prove it with that. You don't get fancy numbers, okay, in the future. You don't get easy numbers to plug in. In the future, you gotta do this stuff with letters. So you gotta get used to this. No, I'm just kidding, though. You're not gonna do that until like you're in college, right? You could probably do it now, but I would rather you not have to go through that right now. Okay, I'm not saying you're not capable. I think you're plenty capable. I think it's really, yeah. I think math is awesome and fun right now, but it can get frustrating at times. Okay, all right, you guys ready? Is this what you guys got? I actually like Meredith and Ruby's because theirs is not quite written the same, but it's actually the same in a sense. Oh, you changed it. Why? Why did you change it? Oh, you didn't?
No.
Oh, you didn't change it. Okay, great. Okay, any questions on this? Why did I make that y coordinate b, by the way?
Because we don't know it.
We don't know it.
We don't know it, but why couldn't I make it a?
Because it's not.
You don't know because it's
Yeah, and I already set something to a, right? Why is it that this coordinate was a half, a over 2? Yes, Ruby.
because it's halfway between 0 and A.
And how did,
Isosceles.
because it's an isosceles triangle, which is trying to imply that this point here should lie somewhere in the middle, okay? All right. Very, very good. So I think I could have sworn, though, someone had this, though. And I thought it was you guys. I thought it was, this is just A and then B, and then this person made this 2A, comma, 0. That would have been just fine, too, as well. It means it's pretty much saying the same thing, okay? So that is also a very, very good technique, okay? All right, now that we know that, are you guys ready for the meat and potatoes of this section?
Potatoes, you say.
All right, I see Katie. She's really excited about this.
Potatoes, you say.
Yeah, she's really stoked about this. She's like, I got my good friend on my right. We're about to do some business. It's going to be fun, okay?
You better deliver on this promise of potatoes, Mr.
All right.
Do not take potatoes lightly.
You don't take potatoes
That-
lightly. Wow, all right. I will try to deliver you the potatoes then. I did not promise the meat, my friend, but the potatoes. Okay, are you guys ready? Because we're going to write. This is still in 6.6. Sorry, so if you didn't know, hold on, let me start over. This is 6.6 triangles. So again, the section number was triangles and coordinate proofs. So this is the main topic for today, or the big section for today, coordinate proofs. And the first big point we're going to hit today, essentially, the big one, is going to be writing. You guys ready for this? Coordinate proofs. Does that excite you or what? Not only are we going to write proofs, we're going to write coordinate proofs. It's going to be great. Okay? So I'm going to give you the triangle. So I'm going to give you a set of axes right here, x and y axes. Not perfectly drawn, but to the best of my ability. And then let's see here. Let me draw a point at the origin, which will be considered A, 0, 0. Okay. And then I'm going to draw a point out here, B. This will be point B, but its coordinates would be 2A, comma, 0. Okay, let me see if it's focusing. Okay, very good. And then I'm going to draw one more point sort of in the middle, but not really. It's a little offset, okay? Okay, so that's my triangle. And then halfway, and then this is going to be point C, which the coordinates are going to be 2B, comma, 2C. And then halfway between A and C is another point, S. And halfway between C and B is also another point, T. And notice I said very specifically that halfway between A and C is S, and halfway between B and C is T. Because technically the given information that you will be given in this case is that there is a triangle ABC. Okay, you see that. That's given to me. Another thing given to me is technically S is definitely the midpoint, M point, it's just M point for AC, line segment AC, and then T is also the midpoint for BC. That's given. You want to see what you want to prove? You guys excited about this?
Sure.
I think you guys are going to love this. You guys are going to have to prove that ST is going to be parallel with AB. I'll give you a hint. You don't have to do anything with angles. No SSS, no SAS, none of that stuff. Just think, essentially, let's kind of work backwards, okay? If AB and ST were parallel, what things do we know about these lines? let's try to come up with things that we should know about these lines that are parallel. We could talk about angles, but like I said, we don't need to talk about angles and side lengths, side, or anything. What do we know about these two lines? What do you think, Matthew?
The angle CST would be equivalent to SAB.
Okay, all right. So let's. I'm not gonna draw it, but I'm just gonna say CST is what is it? What is it? That would make that congruent to CAB. Is that what you're saying? Yeah, that's good. But could you do anything? Could you prove that on a coordinate grid though? Angles and stuff. Okay, not quite. I can't really do anything with these numbers to prove angles, right? What do you think?
For ST and AB, you can find the slopes of those two, and if they're the same, then they're parallel.
Did everyone catch that? If your lines are parallel, what does that tell you about their slopes? They're the exact same. And can I not find the slopes on coordinates? Right? I have coordinate. The only thing I'm missing though is what though? I got coordinates for A and B and C, but which coordinates am I missing? S and T. So what do you think I'm gonna have to do?
Figure those out.
Figure them out, right? Okay, so that's what we're proving. All right. So let's okay, here's my tip. Draw a 2-column proof, but leave space on the left side, okay, to work on. You will need that space. I'm going to write in 2 different colors. You don't have to, but I'm going to write in 2 different colors. And what's the first thing I should write in both statements and reasons? All the stuff that's given. So I'm going to bullet point each point. So there's one point that ABC is a triangle. Another bullet point will be S is the M point for AC. I couldn't quite fit that in. And let's say that T is M point for BC. Okay, that's given to me. So I want to build my way to saying that ST and AB have similar slopes. That will for sure prove that they are parallel lines. But I don't have the coordinates for S and T. Does anybody have any suggestions that we could do to find the coordinate for, let's just focus on S. That's a tough one. That is really, really tough. How can we find the coordinates for S? Do you have an idea, Yusuf?
Use a slope formula.
So if I found the slope between C and A, right? Will that give me the coordinates for S?
No. So, but first you need to find the midpoint formula to find the coordinates of S. Then I find.
Does anybody know what the midpoint formula is for this?
They're like x1 plus like x2, 2, whatever. 2
Yeah.
Plus x1 minus whatever. You know, I just say
Did we maybe go over this?
Yeah.
In the beginning? It's right there. What you guys came up with? That was very good. You're on fire, my friend.
Okay.
Okay, so what we're going to do is we're going to figure out the S coordinate. So here's what I'm going to do. I'm going to say S coordinate. And then you can say is equal to. And then we're going to figure that out on the side. So that's why I wrote it here. And then here, what we're going to do is we're going to apply the midpoint formula, which is technically x1 minus, or x2 minus x1 over 2, comma, y2 minus y1 over 2. It's just what 2 coordinates are we using to find the midpoint, S? What 2 coordinates are we, A and C, right? So C, this would technically be x2 and x1, and this would be, you don't have to write this down. I'm just writing this down as a visual. This is x2 and this is y2. I'm so sorry about that. And then over down here is x2, or x1, y1, right? 0 is x1, and then 0 is y1. And up here, 2b is, what is it, x2. That's x2, and then 2c is y2. So what we're going to do is we're going to put let's see, we're going to put this in here into the formula. So we're going to say that S is going to be equal to, I'm going to start plugging in right away, 2b, which is x2, plus the first x, x1 would be 0 divided by 2, comma. Up here will be, 2c plus 0 divided by 2. What is 2b plus 0?
Just 2b.
2b, and then you divide it by 2, b, just like you said. Okay, so that's my first coordinate, b. And then over here, it's the same thing. That should be c. Everybody get that? And then you knew to do this from either two things, the midpoint formula or the midpoint definition. It's the same thing. You can put it in either or. I think your book specifies as the midpoint definition. Are we finished?
No.
Not at all. Where are we?
Find T as well.
Find T.
We should find, yes, thank you guys. We should find t. So we're going to say t coordinate is equal to, and then we're going to leave a space. Okay. Find the coordinates for that guy, the person, sorry. And then you're going to do the same thing, but say it's t. And then what number should we plug in now? So actually, what points are we going to use to calculate the coordinates for t?
2B, 2C, and 2A and 0.
Or as Ainsley was saying, right? You're saying B and C, right? So we'll take these two coordinates. And here's the tricky part. Which one should I use as x2, y2? It really does not matter, okay? The answer should be about the same. But I think if you want to be classically correct, you always take the person more to the right. So just be a little bit more sequential. X2, Y2 is always the person more to the right of the grid. Okay, so we can do that. So don't be scared. Don't fret. Okay. But it really does not. Oh, I'm not going to say that. Okay. So we're going to take, let's say, X2 or X1 plus X2 or X1, whatever you prefer to call these. You just add these two together. 2B plus 2A divided by 2. Sorry, I'm writing that over here. 2b plus 2a divided by 2, comma, and then the other one is 2c plus 0 divided by 2. We're finding the midpoint between those two. So 2c plus 0 divided by 2. This one's a little bit trickier, so maybe I need to white this out so we have a little bit more space here.
Wouldn't it be minus
Oh, would it be?
the midpoint formula?
No. It is actually plus. Yeah. That would be, wait, so we determined, that's why, because on our notes we said x2 minus x1, correct? Ooh, no, so that is, yeah, I believe that's actually incorrect. That should have been a plus. Yes, that should have been a plus. I apologize. I very, very, very much apologize. That should have been a plus. Okay. So that should have been a plus.
And
So
on the distance formula, would it also be plus or would it still be minus?
no, that's minus. Yeah. Very confusing. Yeah. Very, 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 very confusing. Okay. Okay. All right. So knowing that 2b plus 2a divided by 2, yikes. That looks a little bit scary. Okay. If you wanted me to simplify it, you don't have to write this down. You can keep it nice and clean, but I'm going to make it a little bit dirty. It's like saying 2 times b plus a over 2. And the 2's cancel out, and you will get BA for your first coordinate. B plus A is the first coordinate, or is the first X point in your coordinate. And then 2C divided by 2 is simply C. You might be asking yourself, or you might be telling yourself or telling me secretly in your head, this makes no sense. I don't get it. This is not as clean as I thought it would be. Okay. Step 3 is another midpoint definition. But step 4, I think, is where it all kind of comes together, okay? Because what should we do now? We have the 2 coordinates, right? Now what do we do? What were we doing this, and what were we setting out to do in the first place in this triangle?
ST and AB are parallel.
Parallel, and by which method? By which means? What are we trying to do to prove that these are parallel? Yes.
Find the slope.
Find the slope. So can we find the slope of S and T? Just by looking at it, what do you think the slope of S and T would be? So hopefully, if we cross our fingers, it's going to be 0. So let's double check. Yeah? Okay, so let's look at the slope. Sorry, it's another formula that you might not recognize right away. But slope is what, if we remember, is rise over run. That means the change in the y, which is y2 minus y1 over x2 minus x1. And what we're going to do is we're going to take these 2 points, S and T, and we're going to plug it into this formula. Okay? So I'm going to use T as my x2, or I'm sorry, my x2 and my y2. And then I'm going to use S as my x1, y1. So what I'm going to do is I'm going to put B plus A minus B. Oh, I'm sorry. That's my x's. Sorry. Those are my x values. Those should go on the bottom. Okay. My y values that go on the top. I totally apologize. So what should go on the top is C minus C, or C minus C, however you want to look at it. So C minus C over. Now we plug in B plus A minus B. Let me white that out a little bit more so we have a little bit more space to write. If you think about it, what is C minus C? It's 0 over B minus B is going to be gone, but then we have an A left over. It doesn't really matter what we have left over on the bottom because what are we going to have in total?
0.
Yes, 0, nothing. So the slope, we're going to say the slope of ST is equal to 0. And we know that if we use the midpoint definition to define our reason for finding the midpoints, what do you suppose we're going to put here? Slope definition as well. Boom. So we have the slope of ST. Now we got to do the same thing for AB from points A to B, which I think is a little bit easier because the points are a little bit cleaner. So I know you guys must be loving this, right? I like that. God, no. And you thought graphing was tedious, right?
Well, I mean, it still is.
Oh, it still is. Okay.
This is more tedious.
Fair enough. Fair enough. Okay, so the slope here will be from B or A to B. So we're going to put 0 minus 0. If you can see that there, we're going to take the y values of A and B. We're going to take 0 minus 0. Let's see if I can plug that in. So it'll be, so if you want to rewrite it, it's y2 minus y1. You don't have to do this, okay? This part here. I just want to remind you that we're using the slope definition of the slope formula. So we're going to do 0 minus 0 over 2a minus 0, which will give you 0 over 2a, which would just give me 0. So the slope of AB is equal to 0. By what reason do we do any of this math? And then what do you think my next step is going to be now? What is step 6 going to be?
AB equals to XT.
Is it it's not, oh yeah, it is equal. Sorry, it is equal, but we can actually skip right ahead to the conclusion and just say that because these are equal, you can see them, we will say that they are parallel. The line segments are parallel. And that is literally the definition of parallel lines. Okay? And that is your, what is it? That is your proof for proving this with coordinates now. Do you see how the challenge and the fun sets in when you combine coordinates
Fun.
and angles and triangles and shapes?
Is that fun with an H?
Huh?
Is that fun with an H? This doesn't seem like fun.
This doesn't seem like fun? No, this doesn't seem like fun. Okay, I'm sorry about that. Okay. You guys want to try one now? No, not really. But okay. I promise you this, and I have one more example that you could probably do on your own without even me even having to have you take notes. You figured out how to do that. But for the time being, let me see if I can. This is going to be pretty tricky. This won't be easy. Okay. So please take a gander at this, work with someone, and then go ahead and go on the board and try to come up with a coordinate proof for this guy here. How can we prove that these two triangles are congruent to each other? Now we have to talk about congruence. Yikes. What can we do to figure this out, that they're congruent? I'll give you one. How about the angles? Now we can't talk about angles because it's a... You can just kind of just throw it in there here because you don't have to do any calculations for the angles. What do I mean by that? Is there any angle relationship that I can tell between these two triangles? Yeah, what do you see, Yusuf?
Vertical angle.
What vertical angles are you looking at?
DXA and CX to D.
It's CX to D.
Yeah.
You guys didn't have to do any math. You guys already got that two angles are congruent to each other, right? Just because they're vertical, okay? Can we use any theorems to prove that these two triangles are congruent to each other? Anything with angles? You can do a lot of math and try to find the distances of all these triangles to get side, side, side. But can you think of anything with an angle in there instead of saying side, side, side? Using that theorem. That's my clue to you. I'm going to give you guys about 10 to 15 minutes to work on this one. Find a space on the whiteboard now with a partner and then ponder and meander. What can you do? That's the first thing you need to know is the angles are vertical and curved.
To school. I know that A equals CD.
You said AB is equal to CD?
Yes.
How did you do that?
Because the same X and the top, like O, or not O, AXD and BXC are congruent. And then
I'm sorry. So A what?
AXD.
AXD is congruent to which angle? AXD. So A to X to D is congruent to which angle? B X to C?
Yes.
How is that useful though?
That one thing that the angle with, I don't know what's it called. There's a theorem though.
Yeah, think about that. How is
I don't know what
that?
it's called, but it's like an angle like that. You know that this
Exterior
angle,
angle?
yeah, the exterior angle.
AJ?
It's exterior to.
Big old squares.
Okay, and how is that?
Because since they're equal,
No, you can't.
and AB equals CD.
Okay, again, how is that going to break down?
Is D A 0?
I'm not yes.
So
You gotta figure it out
from the
yourself.
distances, AX is congruent to XC
So AX is congruent to XC.
because X seems to be a midpoint of AX and XC, and I can prove that using the distances.
Or you can just simply show me, if you show me that A, like the coordinates of A plus C divided by 2, if you can show me that it's equal to the coordinates of X, then
Yeah, I'll show you. A plus X by 2 is what X is, and 0 plus B by 2 is what X is, and same with B and D. 0 plus X plus A is A plus X plus
So
2.
then, if you have two sets of sides that are congruent and angle congruent, what do you have?
SAS.
There you go.
And it's an included angle. It's not just angle. It has to, can you prove using ASS? Can you prove that
You cannot. Yes, you cannot do yes. Because you can have triangles that are not congruent and still have that configuration where the angle and side to side are congruent to get the overall triangle.
To there you can prove you just draw a triangle that doesn't follow.
Yes, yeah, exactly. But you cannot draw two sets of triangles that have SAS in that same order, of corresponding sides and angles, and then have them not congruent overall.
And AAA also doesn't work.
No, I believe AAA, yes, AAA does not work, yes. AAS does, but not ASS and not AAA.
Because you can have two equilateral triangles. One, you can have two triangles. Both are equilateral triangles, but one can be like huge and the other can be small.
Exactly. And yet they still have the same angle measures of 60 and 60, right? But yes, you're absolutely correct.
But that you can use AAA to prove that they're similar though.
Yes, you can. With similarity, because we're not talking about
They're similar
congruency.
triangles.
They're similar or proportional, however you want to think about that. But yes, you are absolutely correct.
Oh yeah.
You basically just and then you have the two things SAS.
So
Do you watch the So there are 6 ways to prove a triangle. Do you guess them? Here it is. ASA.
Where is it?
AAA, and HL. Those are the 6 ways. Hypotenuse. If you have 2 hypotenuses that are congruent at a leg that's congruent at a right triangle, and one leg that are triangles, just put one.
These are equal, these are equal.
plus
I think.
then
And then you could like do simple say
The reason why is because you have, and this actually violates the rule. It's actually SA. Oh, you guys actually ASS. But HL is basically like A. For ASS, basically does work with right triangles.
So, what do you think X is in relation to A and C? How can you prove that to me?
Yes.
How would you prove that to me?
Midpoint formula.
Okay, between what 2 points?
We still need to use AAA.
A and C. So why don't you plug them in and show me that if you took the midpoint between A and C, the coordinates are going to be exactly X. That would prove to me that that's the midpoint of A and C. Well, what else would that prove to me, though? What else is that saying? If these two have the midpoint of X, what does that make AX and XC? Same length. Can you not do the same thing with B and D? So why don't you do that first? Prove to me that if you did the midpoint between A and C, the coordinates are X, which means that X is the midpoint for A and C, and then because they're the midpoints, because that's the midpoint, AX to XC are exactly the same. If you do that again here, then you have 2 sides that are congruent, and what else do you have? An angle. So what would that be? Side. There you go. Okay, so try to figure out how you would organize that.
Did you learn HL or no? That's another thing.
No, not yet. Not until much later.
So A
Then you just prove it over here.
plus 2
Okay. Midpoint.
A plus X.
Yes, this is very yes. That's very good.
Plus
Okay, so I need to take time to write down the answer because I realize I haven't written it down. It's gonna take a while.
minus A plus X.
Bear with me. So I'm gonna give you guys about 5 more minutes, which I think is the time it'll take me to write down the answer for this. So we have. Oops.
So then it'd be, that would end up being minus all of that. And then just be that. 2a plus a minus
X.
What's that?
Use this either AAA or HL.
Yeah. Mr. Greenwood basically has 6 answer choices.
SSS, SAS, AAS, AAA, and HL.
And HL is by far the most confusing. By far, so you can just like just a right triangle.
No, you
We didn't do anything. How many followers do you have now?
How many Lego sets you can buy for $1,000? Lego sets. How many Hot Wheels you can buy? You can buy a UCS Millennium Falcon and sell $200. Crazy.
Which is easier to use?
just
There's nothing.
Yeah.
We basically need to take pictures of basically giving the hot book.
get that till they come up with the next one. Yeah.
What's up?
Get pretty easy.
Eric, for the Britney Spears case.
Wait, not the bird
You said expensive.
It says,
He lives
that
in the
like
line.
this point is the midpoint of these two. Basically, that means it's exactly in the middle of those two points. And then you use it to find the coordinates of.
I don't have a really good camera, that's why I don't take any good pictures. I have a pretty crappy camera. It struggles a lot.
I don't think so, because it doesn't say that it's a
Even the flash doesn't help.
So I don't know.
It just gives you some fudgy goes down on the camera. Even in daylight, it doesn't get a lot of, it's not very sharp. So I'm waiting for the next phone to be able to share the
Okay. I just did
How's that?
that.
I'll tell you what this means. Like when you jump, it will basically record 10 seconds of jump. That's what 1,000 seconds is.
Amelia!
Super slow.
Oh, do you have wireless charger? Yeah, we don't have a wireless charger. Well, my parents have wireless charger. They have it too, so it's like we should.
I'll try to
Manufacturing.
I'll purchase that phone and I'll come out and I'll show you all the 1,000 trains and and I think you'll only be able to access
I love it.
Yeah.
It's like,
jump race.
my other phone
I said
It's really nice. Get a smartphone. Because that's what my brother had.
Oh, there's oh, that makes so much more sense. Why would they just make it return? That has to be a movie. That has to be.
yeah, you can control your phone.
Oh wow. Fraternity leave. Fraternity leave.
It's much harder to do.
No.
All right, guys. I'm gonna post up the answer now. You guys can write it down, okay? The way I did that. So let's see. The way I did it.
The smaller one's cheaper.
Okay, so you might have written yours a little bit differently. So let me redraw the triangle really quick, okay? So let me see if I can. Sorry about this one. I'm gonna freeze that for a second. Whoops. Okay, so that's good. Okay, so please go ahead and write that down, and I'm gonna draw the triangle so you can see what's going on. I can redraw it on here so you can see what the heck is going on. Yes.
Same thing, but in a different order.
Yeah, you could do the same thing in a different order too, as well. So, just to reiterate, so let's see what we did here, right? So I suggested that this looks suspiciously like it's in the middle of A and C, correct?
Yes.
So if you could just prove to me in the math that maybe if I took the midpoint of A and C, which I did right here, so that's literally the first thing I set out to do, okay? You didn't have to. You could just, some people just said, oh, I saw the vertical angles like right here and right here, okay? You could write that as step 2. Doesn't matter, okay? Right here. I wrote as step 6. But anyways, I moved to this. I said that I just found out the midpoint of AC. I did not say it was X yet. What I did was I just found the midpoint, this, AX plus the first X coordinate from A, which is 0. So it's A plus X plus 0 over 2, comma, the other one would be B plus 0 divided by 2. And then I found out that that's just the remaining coordinate that I get is A plus X over 2, comma, B over 2, which if you didn't notice is the exact same as what the X coordinate was. That proves to me that indeed X is the midpoint of AC. And I will say that by the definition of the midpoint. And then that's not quite it though. Don't stop there. If we know X is the middle of A and C, what can we say about AX and XC? What can we say about those two line segments there? These two line segments, AX and XC. If X is indeed the midpoint, what can we say about AX and XC? What do you think? Which ones are equal?
Oh, well, AX and CX.
Yeah, that's what I said. That's exactly, yeah.
Same page.
Yeah. And then you could do the exact same thing, and I did so those took 2 steps. The next 2 steps are the exact same thing, only I did it from B to D. Okay, so I literally just found the midpoint from B to D. Okay, so I took A0, and that should be 0 plus X comma B, right? And then I applied it to the midpoint theorem here, or the midpoint formula, and I got the exact same coordinate as what is equal to X. So that confirms to me that X is indeed the midpoint of BD by the definition of the midpoint. That makes XD or DX to BX congruent to each other. And then we also knew that the angles are congruent because they're vertical. So that tells me by SAS that both these triangles are congruent. Yes,
You
Matt.
made a mistake.
Yes. What
You wrote
mistake?
4 twice.
I wrote 4. Oh,
Oh my god, Mr. B.
I am very, very sorry.
Z.
I might break everything we just learned. No, I'm just kidding. But thank you, though. Thank you for showing me. I'm not trying to be mean or sarcastic. I'm sorry about that. It might have came off like that. Okay. Anybody have any questions on this? Okay. Has everybody written this down? I have no. Okay. Go ahead. I have one more problem, but I'm not going to go over it with you as a class. I'm just going to give it straight to you, right? I think you guys can handle this. You might need a calculator. So make sure everybody has a calculator. At least one person in your group has a calculator, okay? And I want you guys definitely now to get up on the board because that was a little bit lengthy. There's no way you could fit all that work on the board. This one is a little bit more clean, this next problem. I think it's going to be pretty simple if you remember the warm-up. You guys ready? Matthew, you still ready? Colin, you still ready? Okay. I have one more problem, and then I'm going to let you guys go. So that clock is sort of fast. No, it's about time. Yeah, it's about 10:27. You have about 8 minutes to finish this. I think you guys can finish this in 8 minutes. But you guys got to know what to do and what to plug in. You guys ready? Okay. Yeah, Matthew. Yes, please erase. Guys, whenever you guys see any writing and I tell you to get on the boards, erase anything that was there. You are now priority on that board. Just write whatever you want. Okay? All right. Okay. Can I ask someone to grab the remote here for me? Yeah. Anybody? Yeah. Ruby. Actually, Ruby's a little closer. Can you grab this remote and press freeze for me?
Freeze. Oh, I see it. Where do I point it?
Yeah, just press it, and then it won't tell you exactly if you press it or not. Okay, cool. Look, my hands. Thank you so much. All right. Do you guys see the coordinates there for O, A, and S? This is from the distances from, guys. This is from destinations of Odessa, San Angelo, and Albany, right? Supposedly, none of the distances are the same, making this a scalene triangle. They made a scalene triangle, right? Can you prove to me that this indeed is a scalene triangle using these coordinates? Because I said so, right? Because it was a given piece of information, and we're done with the proof. Okay, not quite, but how can you prove to me with a formal coordinate proof, but can you prove to me something with these coordinates showing me that this is a scalene triangle? Look at your warm up. I don't want a response. Okay, go ahead. What's your question?
Is that the angle or the side?
These are so those right there, those are coordinates. 31.9 comma 102.3. That's 102.3, not 1023. 102.3. That is 102.3. Okay.
And for S, is it 31.4? And is that 100?
That's 100. Sorry, that's not a P or something. That's 100. Okay. So 31.4 comma 100.5, and the last one is 32.7 comma 99.3. You guys will need a calculator. Hint, hint. And go ahead, go on the whiteboards now. Please go. All right. First group that can get this down 100%, I will give you extra credit. This is the last thing. Just raise your hand and let me come over and confirm. I have the key up here.
Angle O or
that is not. Those are not angles.
those are sides?
Those are sides.
Those are sides, not angles.
O to A. Yeah. So sorry. Yes. Those. That's
Why
O.
does it have a point towards like S and A? The arrow.
So this
Oh, it just means that's the coordinate for S. That's a coordinate for where San Angelo is on a
So is
map.
that the angle?
That is not an angle. It's just a point. What do you do with those points to figure out if this is a scalene triangle?
You see if the angles are the same. Sides?
Yeah, that's
The
it.
angle.
Well, scalene means what?
They have different sides.
And different angles.
Yeah.
Which
So
would you
if I
rather?
find different angles, it has different sides.
But those are not angles. Those are just coordinates.
Or if I find the angles,
How would you find the angles?
I would somehow.
What about the sides? Why'd you discount finding sides?
Because it's easier.
How would it be easier with those coordinates?
Because it is.
What would you plug in to figure out?
I would find the slope. Maybe. No, not the slope.
Does slope tell you anything about angles?
No.
How?
You confused me.
So think about it. How would you? What are they doing up there?
The distance formula.
Okay. For what though? Why would you do
I
this?
saw it on there.
Okay. And what would you? How would you apply the distance formula to this point?
Well, I find the distance between O and S, S and A, and O and A.
And then what should they be if this is indeed a
Different.
scalene triangle? Okay, go ahead and do that. Okay. It's one thing to prove to me they're scalene. These sides. Cool, right? Think about that, sides. But it's another thing to actually get the actual values correct. So if your values are incorrect, okay, I can't give you the extra credit points.
So doing okay, right?
Yeah.
So then, think A would be the X2 and Y2.
Can I borrow a calculator?
Yes, you may. Go ahead and grab one from the drawers over here. Yes, the drawer. Wait a minute. Is this someone? Ah, man.
Young lady.
Did she? No, she returned it. This is a very personal calculator.
It's perfect if you want to like movement. That's the reason why I'm buying it. Just check it out.
Does that say that? Is that 99.3? No.
Yes, that is 99.3. Guys, that is 99.3. Okay? 99.3. 99.3.
And then 102.3 or just
Yeah, that's 102.3. Correct.
This is the same formula.
Yes, that is. Whoops, what the heck?
Apparently, he's one and on for best right?
So I rewrote it. Hopefully you guys can see it now. Yeah? Yeah, you guys found it? Okay, so. Alright, and you guys are free to leave now, so that's it. Yeah. Okay, if you think you have the answer, please let me know. We'll go over and check. Huh?
Yeah.
No calculator? Go ahead and borrow one. Borrow mine. And if you have a class, I would start packing up right now. It's about 10:33, so you don't have to stay here and do this.
Senor Hui.
Yes.
Come here, please.
Come here.
Just come here.
Come here.
Come on over, bro.
Yes.
Alright, so we didn't finish all that, but they're all different.
They don't look.
They're not the same.
Yeah, they don't.
Okay, I copied them now. You can't use them.
Genius, high five.
You take it off?
Yeah, I'm taking
So
off.
smart.
Do you have like a math help like on Monday?
No.
No, or well, math is on Thursday.
You can come in on Tuesday or Wednesday.
Okay. For Tuesday, can I come a little early before the chemistry test? I need to put up just a few things.
You need to come during the Tuesday. Do you have a class or something?
Well,
It's hearing on Tuesday. It's around 8:30.
yeah, I don't have a class.
Yeah.
Chemistry is my first class.
Come in during that time. Okay, so where are you guys right now? So, alright. Goodbye, good sir. Okay, so boy, you got, what is that? 30, 30.
Yeah, because those are both squared and that's the square.
102.3.
Squared.
Well, because it didn't have much. We're also mad.
Okay, I didn't do this part, but this is correct. AS, where's AS?
That's this one.
Okay.
That's this.
Okay, that's good. Plus, let's try this again. Okay, and you have to take the square root of that, though. So,
I think this is OS.
here. Oh, I see. This is okay, got that. That's good. Can't do that. Oh, you guys didn't do that. Okay. You guys did. Okay. All right. Anybody else?
Yeah, over here.
Over here. Come here. Okay. Come here. What'd you guys get? Okay. Away. So these are. So hold on. So essay, you got 32.7 minus 31.4 squared. Huh? You got that first. Oh, so when you do this, calculate that first, then take the square. Don't do this one. So what you did was you everything
So you that square.
plus. So what you're gonna do is plus 1.3 squared plus negative 1.2 squared. Add those together. Then
How would I
take the
just give
square.
it back?
Add. No, so square, then add them together. Square this and this, then add together, then take the square. Okay. So,
I have an answer.
so this is a good exercise in using word operations. What do you guys do for OA? These are not correct. So where did you? So let me have it again. Oh, it's minus. That's why. It's okay. It's okay. It's okay. It's okay. I mean, like we need to identify this before these games. Just let you know. Okay. So this was good. Yes. No. It's okay. No notes this one. Yeah. Okay. Good.
Wait, there's no notice?
No, no.
So I said there is no even though it doesn't say no.
No, what did you say?
No notes?
Yeah. Does that help? No, no. What did you do? You guys have a lot in your mind for the finals. Yes.
You good, Tola?
Everything was good. OA though was funky. You see OA. What did you get for OA? It's 2 It's not 2 though. I didn't get 2.
Well, yeah.
Wait,
If that's a 2.
it's supposed to be.
Way up square.
So I do this.
Whoa.
I spread them apart.
And then take the square root of that, of what they are added together.
Okay, good. Where's my list? Where's my list? Oh, and I was recording for you, Ainsley. So. I believe it's still going.
English?
Yep.
Muffin.
Yeah.
Genius.